Module 2, Computer Fundamentals, one of the most important modules in your BCA journey. Before learning programming, databases, networking, or artificial intelligence, you need to understand how a computer actually works. By the end of this lesson, you'll know the difference between hardware and software, understand input and output devices, learn where data is stored, and discover how different computer components work together. So without wasting any time, let's get started. Slide 1, Hardware versus Software. Before we learn how a computer works, we first need to understand what it's made of. Every computer has two essential parts, hardware and software. Let's start with hardware. Hardware refers to all the physical components of a computer that you can see and touch. Your keyboard, mouse, monitor, motherboard, RAM, hard disk, and CPU are all examples of hardware. If you buy a brand new laptop today, everything inside that laptop is hardware. Now let's talk about software. Software is a collection of programs and instructions that tell the hardware what to do. Unlike hardware, software cannot be touched because it exists digitally. Examples of software include Windows, Linux, Google Chrome, Microsoft Word, Adobe Photoshop, and games like Valorant or Minecraft. Here's an important point to remember. Hardware and software always work together. For example, when you press a key on your keyboard, the keyboard sends the input to the computer. The operating system receives that input and performs the required action. The keyboard is hardware, while the operating system is software. Without hardware, software has nowhere to run. Without software, hardware cannot perform any useful task. One more exam point. Hardware can become physically damaged over time, while software doesn't wear out physically but can become outdated, corrupted, or infected with malware. So remember this simple definition. Hardware is the physical part of a computer, while software is the set of instructions that makes the hardware work. Now that we know what a computer is made of, let's see how we communicate with it. Tap slide 2, Input Devices. Every time you type on your keyboard, click your mouse, scan a document, or speak into your microphone, you're using an input device. An input device is any hardware component that allows users to send data or instructions to the computer. The most common input device is the keyboard. It's used to type letters, numbers, symbols, and commands. Next is the mouse, which helps us move the cursor, select files, open applications, and navigate through the computer. A scanner converts physical documents or photographs into digital files that can be stored and edited. A microphone captures your voice and converts it into digital signals. It's used for online meetings, voice recordings, gaming, and voice assistants. A webcam captures images and videos, making it useful for online classes, video calls, and content creation. Modern devices also use touchscreens, where you can interact directly with the display using your fingers instead of a keyboard or mouse. Another common input device is the barcode reader, which is widely used in supermarkets and shopping malls to scan product information quickly. Although these devices look different, they all perform the same basic function. They collect information from the user and send it to the computer for processing. A simple way to remember this is if data is going into the computer, it's an input device. But once the computer processes that information, how does it show us the result? Let's understand that next. Slide 3. Output devices. Output devices allow the computer to present processed information back to the user. Simply put, they help the computer communicate with us. The most common output device is the monitor. Everything you see on your screen, text, images, videos, websites, games, and applications is displayed through the monitor. Another important output device is the printer. Instead of displaying information on a screen, it prints digital documents onto paper. Inkjet printers are commonly used at home, while laser printers are faster and mostly used in offices. For sound, we use speakers or headphones. Whether you're listening to music, attending an online class, or watching a movie, these devices convert digital audio into sound. A projector displays the computer screen on a much larger surface, making it ideal for classrooms, seminars, and business presentations. Finally, we have a plotter. Unlike a regular printer, a plotter is designed to print large and highly accurate engineering drawings, maps, and architectural designs. The easiest way to remember the difference is input devices send data to the computer, while output devices receive processed data from the computer. Now that we know how information enters and leaves the computer, let's understand where it's stored. Slide 4. Storage devices. Every photo you save, every application you install, every assignment you create, and every game you download needs a place to be stored. That's the job of storage devices. A storage device saves data permanently, even after the computer is switched off. That's why storage devices are called non-volatile. One of the oldest storage devices is the hard disk drive, or HDD. An HDD stores data using spinning magnetic disks. It offers large storage capacity at a lower price, making it a good choice for storing movies, documents, backups, and other large files. However, because it has moving parts, it's slower than modern storage devices. The modern alternative is the solid-state drive, or SSD. Unlike an HDD, an SSD has no moving parts. It uses flash memory, making it much faster, quieter, more durable, and more reliable. This is why most modern laptops and desktops now use SSDs. For transferring files between devices, we commonly use USB flash drives and memory cards. They're portable, easy to carry, and useful for moving files from one computer to another. Another popular option today is cloud storage. Instead of storing files only on your own computer, cloud storage saves them on remote servers connected through the internet. Services like Google Drive, OneDrive, and Dropbox allow you to access your files from anywhere, as long as you have an internet connection. Here's a quick comparison that's useful for exams. HDD, more storage, lower price, but slower. SSD, faster performance, more durable, but slightly more expensive. USB drive, best for carrying files. Cloud storage, best for accessing files from multiple devices. Storage keeps your data permanently, but when you're actually working on that data, the computer first loads it into memory, which is much faster. Let's understand the different types of memory in the next section. Slide 5, memory, RAM, ROM, and cache. Now that we know where data is stored permanently, let's understand something that many beginners find confusing. Is memory the same as storage? The answer is no. Storage is used to save data permanently, while memory temporarily holds the data the CPU needs while the computer is running. Let's begin with RAM, which stands for Random Access Memory. RAM is the computer's temporary working memory. Whenever you open an application like Google Chrome, Microsoft Word, Photoshop, or even a game, it is first loaded from storage into RAM. Why? Because RAM is much faster than a hard drive or SSD, allowing the CPU to access data quickly. However, RAM is volatile memory, which means it loses all its data when the computer is turned off. That's why it's always important to save your work before shutting down your computer. Next, we have ROM, or read-only memory. Unlike RAM, ROM is non-volatile, meaning it keeps its data even when the power is turned off. ROM stores permanent instructions that help the computer start. One important program stored here is the BIOS, or UEFI, which checks the hardware and prepares the system before the operating system loads. The third type is cache memory. Cache is the fastest memory inside a computer. It's very small in size but extremely fast because it's located inside or very close to the CPU. Instead of repeatedly fetching the same data from RAM, the CPU stores frequently used information in the cache. This reduces waiting time and improves overall performance. Here's an easy way to remember the difference. Imagine you're studying for an exam. Your bookshelf is your storage because it keeps all your books. The books you've placed on your study table represent RAM since you're currently using them. And the notebook that's already open in front of you is cache memory because it's the information you need immediately. The closer the data is to the CPU, the faster it can be accessed. A simple memory hierarchy to remember is cache, RAM, storage. Now that we've learned how the computer accesses data quickly, let's look at the component that actually processes all this information. Slide 6. Processing unit, CPU. The CPU, or Central Processing Unit, is often called the brain of the computer because it performs all the processing. Every task you perform, opening applications, browsing the internet, watching videos, writing assignments, or playing games, is processed by the CPU. The CPU has three important components. The first is the Arithmetic Logic Unit, or ALU. The ALU performs all arithmetic calculations such as addition, subtraction, multiplication, and division. It also performs logical operations like comparing values and making decisions. The second component is the Control Unit, or CU. The control unit manages and coordinates all the activities inside the computer. It receives instructions from memory, understands them, and tells other components what to do. The third component is the registers. Registers are tiny storage locations inside the CPU that temporarily hold data currently being processed. Because they're located inside the processor, they're incredibly fast. Now let's understand how the CPU works. Every processor follows a process called the fetch, decode, execute cycle. First, the CPU fetches an instruction from memory. Next, it decodes the instruction to understand what action needs to be performed. Finally, it executes the instruction and produces the required result. This entire cycle repeats millions or even billions of times every second. Modern processors also have multiple cores, allowing them to perform several tasks simultaneously. So remember these key points. The ALU performs calculations, the control unit controls all operations, registers temporarily store data, the CPU follows the fetch, decode, execute cycle. Now, all these components need something to connect them together. That's where the motherboard comes in. Slide 7, Motherboard Explained. The motherboard is the main circuit board of the computer. Its job is to connect every hardware component and allow them to communicate with each other. Let's look at some of its important parts. The CPU socket is where the processor is installed. The RAM slots are used to install memory modules. PCIe slots allow you to add expansion cards such as graphics cards, Wi-Fi cards, or sound cards. For storage devices, the motherboard provides SATA ports, which connect HDDs and SATA SSDs. Modern motherboards also include M.2 slots, which support high-speed NVMe SSDs. You'll also find the BIOS or UEFI, which starts the computer and checks whether all the hardware components are working properly. Finally, the small CMOS battery stores important settings like the system time and BIOS configuration, even when the computer is turned off. Remember this important point. The motherboard doesn't process data or store files. Its main job is to connect all the hardware components and allow them to work together as one complete system. Without the motherboard, none of the computer's components would be able to communicate. Now let's quickly revise everything we've learned. Slide 8. Let's quickly go over the key points from today's lesson. A computer is made up of hardware and software. Hardware includes the physical parts you can touch, while software consists of the programs and instructions that make the hardware work. Input devices send data to the computer, and output devices display the processed results. Storage devices save your files permanently. An HDD offers larger storage at a lower price, while an SSD provides much faster performance. RAM is temporary and volatile. ROM stores permanent startup instructions. Cache memory is the fastest memory and helps the CPU access frequently used data quickly. The CPU processes every instruction using the fetch, decode, execute cycle. Finally, the motherboard connects all the hardware components so they can work together efficiently. If you're preparing for exams, make sure you understand these 4 topics clearly. Difference between hardware and software. Difference between RAM and ROM. Difference between HDD and SSD. Fetch, decode, execute cycle. These are among the most commonly asked questions in both exams and interviews. And that's a wrap on Module 2, Computer Fundamentals. I hope this lesson helped you understand how the different parts of a computer work together in a simple and easy to understand way. If this video helped you, consider subscribing to Untitled Tech. We're covering the complete BCA syllabus, one module at a time, with beginner-friendly explanations. You can also download today's notes and presentation from the link in the description. If you have any questions or suggestions for future videos, feel free to leave them in the comments. Thank you so much for watching. Until next time, keep learning, keep building, and remember, every expert was once a beginner. I'll see you in the next lesson.